All right, part 3. Down here at 33 is the start of the exponents. All right, when things are in parentheses, 3z to the 8th with a 3 outside. That means we have 3 of these, because some people can't remember whether they're adding or multiplying. If we can think of the fact that there is an exponent on the side, if you have 3 to the third, let's go with 5 to the third power. That means that's 5 times 5 times 5, okay? So that we have 3 of those. So that means when we need to distribute these in a way that we're multiplying. If you have this out here and a parenthesis in between two exponents, that's when you multiply, okay? So that 3 has a 1 and that z has an 8. So 1 times 3 is 3. 3 times 8 is 24. So that all distributions have to be taking place first, right? And then once you get that, you can either think to yourself that this z is moving up, or you're doing this math here. You're doing 24 minus this little bar. This division bar means you're subtracting right there. And then you're subtracting a negative 3. So that's 24 plus 3, which is 27. So that's a lot of z's, okay? And don't forget to evaluate, or go 3 times 3 times 3 is 27, not 3 times 9, okay? All right, this one, I find this one the easiest way to do. There is another way to do it. Some people like to change any negatives into positives to start with. And I think your book even tells you that you should flip them. So this would be a to the 4th, b to the 8th times 4, and then multiply, which would give you a to the 16th over b to the 32. If that works for you, great. If you want to do that, that's a lot of thinking and flipping, okay? This one is just straightforward. This gets multiplied because there's a parenthesis in between the 8 and the negative 4. So negative 4 times negative 4 is a positive 16. A negative times a negative is a positive. And then 8 times a negative 4 is a negative 32. And then to put our answer in the final form you need, this is positive, so it goes in the numerator on top, and this is negative, so it goes underneath to take the negative off. On the final, none of your final answers should have negative exponents unless they're scientific notation, okay? All right, so this polynomial is out of the proper order. When I say that, I'm talking about exponential order. So the leading term is right here. So that answers these questions down here. What is the leading coefficient? That's the leading term because that's the leading exponent, which is what the polynomial is for. This is a 4th degree polynomial because that's the largest, greatest exponent in the polynomial, okay? But the way it asks here, it just wants to know what the first one is. So you write down the whole term. Do not forget to put the negative here. On the final, watch the points. Just not reducing your fraction, not putting the decimal in the right place, not putting negative there when you need it is going to be an error, and you're going to get dinged a lot of points. It's just still wrong. So make sure that you're getting all these little details, okay? There's the next term. There's the next term, there's the next term, there's the term. Degree is the same as an exponent, okay? So the degree of the first term is a 3, and the 5x has a degree of 1 because there's a 1 there you don't see. The 6 has an x to the 0 power, so there's a 0 degree on that term, and then the 4 and the 2, okay? So all the terms have a degree. You just might not be able to see them, okay? And then the coefficient is always the number in front. So that's still a coefficient even though you don't see this part. So don't forget to include the signs in the coefficients, okay? Scientific notation. Let's see. So the decimal's here. So I like to just take the number part. If the number part itself isn't in scientific notation, kind of write it off to the side, and then where would the decimal go to make it proper scientific notation? To turn this standard form into scientific notation just in itself, it has to be moved 2 decimal places, and it was a really tiny number, so that means it's 10 to the negative 2. I can't remember to the left or to the right, so I just say, if I can put this back in my calculator and get that number, then I've made it in the right direction. If that was a positive 2, then this would be 384. It's not. It's this little tiny number. So it's this number times 10 to the negative 2. All right, that's just the number part. And then scientific notation always has this 10 times 10 to the something power. So what I do is I figure out the number part by itself, and then I bring this back down. So this is just kind of added on. So this is 10 to the negative 2nd plus 9, which is 10 to the 7th. So that's my final answer there. Okay? When I'm multiplying scientific notation together, I multiply the number part there. I'm sure there's a more technical term for that, but let's go with the number part. Is that number, which is in the decimal where we want it to be, and then we take this exponent plus this. These bases are the same, that we're multiplying them together, so therefore we're adding their exponents. So that's a 31, and then we put both parts together for our final answer. This decimal, this is in standard form. I need to move it right there to put it in proper scientific form, which is 1 digit on this side, on the left side of the decimal point. And how far did I move it? I moved it 2 places. This is a large number, not an itty-bitty number, so this is a positive 2 for our final answer. All right, this one bothers people because it doesn't have a 1 right there. I like to put the 1 in, and then you're taking a negative 1 and distributing it. That makes this a negative 10. Distributing this makes a negative 1 times a negative 1 is a positive 1. Then a negative 1 times a positive 9 is a negative 9. That's all I'm doing for my first step, okay? This is a trinomial minus another trinomial. So you have to distribute that negative to all the terms. Then you have to go find like terms. There's an x to the 5th and there's an x to the 5th. When we're multiplying, and you have an x to the 5th times an x to the 5th, you can add their exponents, and you have x to the 10th, okay? But when you're adding, and you have x to the 5th plus x to the 5th, that's the same as having 2x to the 5ths, okay? So watch how you combine these things. And then the 2's, and then you have 1x, and then you have one constant term, so that goes on the end. So that's how you would combine these variable terms in a polynomial, okay? This next one here, you want to substitute a 2 for everywhere there's an ax. So right here there's an x to the 4th. That one doesn't have an x. That one's x to the 2nd. So I'm writing all these in. I would write that step. Make sure you're showing your steps on the final, okay? That's a step. That's done properly. Now, if it messes up after that, maybe you can get some partial credit on that. So let's do one thing at a time. Right here, that's a negative 16. Right here, this is not 2 times 4. This is 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 16. Okay, didn't do anything to the negative 8. Over here, watch what you're doing. You cannot do 4 times 2 first. You must follow PEMDAS and do 2 times 2 is 4, then multiply. Okay, this is this here first, which is 8, then multiply. Don't forget this negative here, and then add everything all up, and you should get the negative 24. Okay, to divide, it's called turning it into the sum of fractions. Okay, so this number goes as the denominator of all the individual terms and reduce each term. A negative 6 divided by 3 is a negative 2. 7 x's on top, 3x's underneath. That is x to the 7th minus 3 is x to the 4th, if you want to think about it that way. Or there's more x's on top. In fact, there's 4 more x's in the numerator than there is in the denominator. So you have lost your fraction altogether. Some of these get left. So if you had negative 6, 3 over 3x to the 4th, that would be a little different. That would be a negative 2 on top and an x left over underneath. So it is what it is. So be careful when you're working through these. All right, 12 divided by 3 is 4, 1 extra x on top, and then the same thing divided by the same thing is a 1, and then this extra negative makes it a negative 1. Okay, 12 over 12 still equals 1. It doesn't equal 0. So 3x over 3x equals 1. Okay, not 0. So you must show that last term in there. Let's do 2 more, and then I need to do another video. All right. The square of a number. So a number is the x part, and if it's the square of it, it's x squared. Minus 2 times the number, 2x, is equal to a negative 1. Write that all down. Oops, write that all down. Then notice that this is a quadratic equation. If it's a quadratic equation, our goal is to put all the terms on one side and get 0 alone on the other side. Okay? If it was a linear equation, we would put all the variable terms or all the x terms on one side and all the constants or just plain numbers on the other side. We would do that. But when it's squared, when it's a quadratic, we want to have 0 alone on one side. All right, so we need to move, and this x squared needs to stay positive, so we're going to move this negative 1 to the other side by adding. That makes that a 0 on that side, and these are not like terms. Do not add that 1 to something else. This is your trinomial that you're about to factor, okay? So this is an easy factor, x, because there's a negative first, then a positive, then my answer are 2 negatives. You have to have this memorized. If your trinomial has 2 positives, then your answer has 2 positives. If your problem has a negative and then a positive, then your answer has 2 negatives. Okay? If you have a positive and then a negative, then you're going to have 1 positive and 1 negative. If you have 2 negatives in your problem, you're actually going to have a positive and negative in your answer. Okay? So be careful with that one. So that's how you know it's negative. And then factors of 1 that add to a negative 2 is just going to be a negative x minus 1 twice. Okay. All right, I'm going to have to put the rest in another video.